Where there is a copper coating. Then we're going to use the milling machine to mill out our track. And eventually what you will get is something like this, where you have all your tracks and pads for your electronic component. Now for electronic component, we are going to stick to SMT components. So there is no through holes. In most of the electronics you have seen, at least in India, the components are through holes. So you have resistors with two leads coming out. But in this area, we're just going to focus on SMT because we are not drilling holes, we're just creating tracks. The benefit is it's very small. It has a very small package size. So a lot of circuitry can be shrink to a very small size. This is more useful for like wearable technologies and all. So now why don't all of you guys like stand here so that you can look at the machine, and then I can start with the demo part of it. So just to give an idea of how this machine works, so you have a base where you mount your PCB. So it moves in y direction. So if I do this, you can see the base is moving in y direction, and then you have a head which moves in x direction. There is an end mill attached to it. So what it does, it just comes here, and depending upon the signal it gets from computer, it's going to mill your board. You can change the end mill. So there is like two different screws which you can take it out and then change the mill. We usually use two different kind of end mill. So one is 1/64 and 1/32, and the one which is smaller is used to create tracks, and one which is big is used to actually cut out your board. One thing you want to make sure is the machine is properly flat, otherwise you won't get a very good milling pattern. So what I have done here is there is a sacrificial layer. So if by accident you go a little deep, you don't hit your base, you will only hit the sacrificial layer, and eventually like once the sacrificial layer is gone bad, you can simply replace the sacrificial layer and you don't have to replace the entire board. Okay, so right now there's someone who already made the board. I'm just going to remove this, and once I remove this, I'm going to put this there. So to remove this, we usually use the steel rulers. So just go at the side and take it out. So you can put it here. Then I'm going to use a double-sided tape to stick this PCB over here. Of course, before that, I want to make sure that my surface is very clean. I'm going to give them some. And take it out. So I usually check it if it's perfectly flat or not. This looks good. If it's really like bent, then you don't want it to be putting there. You can either try to bend it in opposite direction to make it flat first. And always avoid making fingerprint contacts with the copper clad, because what will happen is eventually when you will mill the board and try to stuff your components, it will be very difficult to solder it. Okay, so then you can simply, so this is double-sided tape. Simply take this and put it like this. Usually like 3 tapes are fine. Okay, now once you do this, you can put it so that it's aligned with this corner. I'm gonna do just like this. Okay, so now I need to press it, but I can't press it with my hand because all the oil from my hand will go. So I'll just grab a piece of paper from here and use that to simply press it. And again, you have to make sure that the corners are flat, otherwise it will create a problem later on. So I can gradually press it. And now it looks like it's perfectly attached. The second step is there are two different mills, as I said before, one 1/32 and 1/64. The one which is smaller is used for milling the track. So I'm going to first mount that. So to mount that, all you need to do is there are two different screws. One is here and one is directly opposite to that. So just hold it like this and simply unscrew it a little bit. Go to the opposite side of the screw and then screw that. So just to give you a demo, this is 1x32, which is slightly bigger, and this is 1x64, which is slightly small. You can just keep it here. There's a magnet to hold it. Now we're going to mount this one. So again, this push it all the way in. All the way in. And once you tighten it, so because this, these are the fine threaded screws, so you don't want to over tighten it. So just make sure you just finger tighten it. The other thing is you want it to be exactly at the center. So you want both the screw to be like pushing it from the same distance. Otherwise, it will be not at center, and when it's rotating, it will rotate like this. So again, go here. First gently tighten it from one side, then rotate, gently tighten it from other side. So this will make sure that the bit is exactly at the center. And then go back to the first screw, finger tighten it again, and then finger tighten it again. Now this machine has two modes. One is the view mode, which is it in right now, where you can actually see your board. So in view mode, what happens is your board will come out and you can see it. In milling mode, the board will be behind it, go in all the way in. So to switch into different modes, you just have to click this button, which is view mode. And if the green LED is lit, that means the view mode is activated. So right now the milling mode is activated, and the board is all the way in. Once I mill it and I want to see it, I'm just going to click view mode, and the board will come all the way in. The base will come all the way front. So whenever you're mounting or your board, or whenever you're taking out your board, you want to be in the view mode. So view mode also makes sure that this is not turned on. So one of the safety hazard is if it's running, you don't want your hand here. So once it's in view mode and you're taking out these things, this will make sure that your this thing is actually turned off. Okay, so I'm going to go back to the previous mode, milling mode. So the second thing we're going to do is, this was all mounted. The next thing is we're going to go to computer and start controlling the thing with our computer. The password for this computer is Fab again, so just click on Fab. Now the instructions to use the software is already here, so I'm just going to copy paste those things. So first open one terminal, just open terminal this, and simply type this command, which is mod _ serve. So this will start the server. Now once you have this server started, you can open another terminal, and then it says navigate to the directly web modules HTML-master, which is this fab HTML. So I renamed it. So just I'm going to go to CD desktop, then ls, then I'm going to go to fab HTML ls. Now I have to type this command, so it's going to be python -m simple http server. So that will start another server. Now I'm going to go to Firefox. And start localhost 8000. Okay, so this is a web-based software which you can use to control all the machines. It can control your Modela, it can control shopbot, it can control and other things, laser cutter also. It can't directly control the shopbot. It can create a file that can be used in shopbot CAM software. Okay, so once you open this, so all these things are called fab modules. So once you open this, the first thing you're going to do is load your settings. So you go to input, load settings, and the desktop fab HTML folder, you have mod settings. So simply just open that. Now once you have done that, what you're going to do, what we are trying to do here is we're going to make this board, which is an RGB board. Looks like this. So here you have your microcontroller, which is ET45. This is your RGB LED. Now LED needs a resistor to limit current, so there's 3 resistors here. This is the ISP connector. So some of you are familiar with the microcontroller programming. So this is for in-system programming. Then you need a capacitor and a resistor for the microcontroller to operate. This connector over here is a power connector. So this is the board we're going to make. Again, this is how we designed it in your circuit. So it is you can use Eagle or KiCad or any other software you use to make the circuit diagram and then make the board. Then you're going to export it as a track file. So this is the track file which Fab module will use, and then use that file to actually mill your board. And the other file is this one more file which is not here right now. Okay, so what we're going to do is again go back to Firefox. So our input is PNG file. Let me do some other thing. So go to first go to Fab module, then go to images, select PNG. So this is going to ask you for a PNG image. So I have that saved in my desktop. Demo boards, we are going to make RGB boards or RGB boards, and then the traces. So this one is the one which we're going to do. So again, this is going to show the image we opened. Then the output format can be different ones. So it can be laser cutter, it can be roll and Modela. So we're going to select roll and mill, which is this machine. So the file format for that is .rml. So just click on .rml. Now there are different processes. Same machine can be used for milling the board, can be used for cutting the board. It can be also used to mill machinable wax to create molding and casting. So for right now, what we are doing is we are using it for milling traces. So it's going to be PCB traces, and the mill bit is 1/64. And once that is done, first you're going to move it to a certain location. So what I'm trying to do is I'm going to move this mill bit right below it, one of the corner, so that will be my origin. No, there are multiple mill bits, so that depends upon different applications. So you want smaller bits for milling finer traces, and bigger bits for milling, say, cut the board or wax, machine the wax. Okay, so once again, what we did is we started with our Fab modules. We loaded our image, which has traces for our board. Then we selected the process, which is milling traces, and the mill bit for that is 1/64. The next step we're going to do is we're going to make sure that our mill bit is right below our board. So for that, first I'm going to reduce the height. To reduce the height, you have two buttons. One is up and one is down. So up will be used to increase the height, and down will be used to reduce the height. So I'm just going to press and hold it. So it's going to go down. Okay, so I'll stop around that. Let me do a little more. Okay, so now you can see that your mill bit is slightly off. We want it over here, and it's over here. So what we'll do is we'll just do hit and trial. We'll try different settings here, move it, and see if we are going to the right location. So this is X and this is Y. What it tells me is I have to reduce the X a little bit. So let's reduce X to say 10 mm. Move it. Okay. I can reduce a little bit more. So let's make it 0.5 mm. Okay, this is more or less fine. Let me increase Y a little bit more. So right now it's 20. I'm going to change it to 25. Let's increase this to 10. Okay, so can anyone now you can see that your mill bit is on top of your board which you want to mill. Okay, everyone can see that? Okay, perfect. So the next step is to actually zero the Z, and the way we do it is we can just lose bit and let it fall and rest on the board. So that will make sure that that is your zero height. and the software is just going to increase the height to say minus 1.0 mm, so it will go deep and then will start milling. Okay, so for that again, all you do is lose one screw, then lose the opposite screw, and this will fall. I usually do this action to make sure if there's a dust, it will just go away. And tight it. So again, first loosely tight one side, go to the opposite screw, loosely tight the opposite side, then go back to the previous screw and finger tight it, and then finger tight this one. Okay, so this makes sure that the current height is zeroed, the Z height is zeroed. Now what we're going to do is we're going to calculate the tool path based on our traces. So for that, simply hit the calculate button. So this is going to create the tool path. So the blue line you see is basically what will be milled, and the red line is like moving from one location to other location. Okay, so in an ideal world, the default setting for depth is 0.1 mm. It works most of the time. I usually change it to 0.12 or 0.14 depending upon how flat my base is. So I did it before in this machine. I know that usually 0.14 works quite well. So I'm just going to do that. And once you are done with that, all you need to do is hit the send button. So when I hit the send button, the computer is going to send the code to operate the machine, and it will operate according to the traces. So let's just see send button. Okay, so now you can see that it's actually not milling it, and the reason behind that is my Z was not perfect. So maybe my board was like this, so I Z0'd it here, but it went here, it's not quite milling it. So what I'm going to do is I'm going to go back, let it finish first, do the Z here, again do the calculation and send again. So we're going to wait for this to finish. Again, you can see that it's milling part of the board and it's not milling the other part of the board. This process, depending upon the size of the board, can take anywhere from 5 minutes to 10 minutes. Any questions so far?
How to set the reference point origin?
Yeah, so remember I unscrewed it and then let it rest on the board.
Okay.
So that is
that's in Z direction. I mean in XY direction. How to set origin?
Yeah, so remember I was moving it like manually to one location and another, and then figuring out if it's on top of my board. So that was my X and Y origin, and that I did by changing the value X mean and Y mean here, and then moving my head to that particular location. So when it sends the command, it assumes that the current position is the origin. And sometime what happens is your mill bit is actually broken, then it won't mill. So whenever you are mounting it, you have to visually check it if it's broken or not. The mill bit, which is 1/32, usually it's very difficult to break because it's big and it has more strength. But the smaller mill bits sometimes breaks very easily. So once you see something like that where you have where it's not milling the board, the thing is either try to re-Z it again or check the mill bit.
Is it possible to vary the width of the line?
Width of which line?
Like if I want the power line to be of more
Yeah. So that will be all done in your design software like Eagle. So a ground plane needs much more current. So in Eagle you will design your circuit so that it has bigger tracks.
So it will decide the path it takes.
No, so what all this software is doing is it's just using the PNG which was created from Eagle. So if Eagle you create like bigger tracks and then export it as a PNG, the PNG will have bigger track, and all this software is using that PNG to then mill your tracks.
So does that entail a change in the midway? Does that entail a change in the midway? In between, is there a situation where we have to change the bit?
No. Once it starts milling, you don't have to change the bit. You will change the bit once you have milled the traces and you have to cut the board. For cutting the board, we have a different mill, and I'll show you that once we'll let it finish. I'll re-zero it, then I'll do the thing again.
But if there is an error, in the sense, like if the aperture is slightly, like what you said, it's milling in one part and the other is not being milled, or if the bit is broken and you notice it visually, so can you restart the entire program and it's not an issue that it goes all over again?
No, so the thing is, even if it goes to the location which is already milled, it's just gonna go and pass it.
Right.
They're not gonna be any issue.
Okay. So just correct the aperture and continue again.
Yeah, so that's what I usually do if I mill a board and part of the board is milled and part of the board is not milled. I just increase my depth or re-zero it and then mill it again. So it's just gonna mill the other part which was not milled. You can try to pause it and stop it also. If it's like 3 minutes or so, I just don't bother doing it because the time you will take to stop it, by the time it will already stop. But if your job is say 20 minutes, you can stop it in between by clicking the button.
So what if I want to try a double layer PCB?
Yeah, double layered PCB. So the maximum you can do is double layer. You can't do more than that. So these PCBs, for example, you can see there's a copper clad here, and if you flip it, there's a copper clad here also. There are some PCBs which have copper clad only on one side. So if you flip it, there's no copper clad. So what you will do is you mill your board, you take it out, you flip it, put it back again, and then mill the back side of it. So you'll have track this side, you will have track this side. Then you have to drill holes to make VRs.
That's a wow.
Yep. Okay, so
Are we using the same bit or should we have another bit?
it's so all the tracks are done with the same bit.
Through hole, what about through hole?
Through holes will be done with 1 by 32. So again, if I look carefully, because I zeroed it here, it was milling it here, and I know that the board is not flat. So what I'm going to do is I'm going to zero it here and then mill it again. Then I quickly check if the bit is broken or not. Yes, so far bit looks good. Okay, so let's move it to say x min is 10 right now. I'll move it to 30. So I'm going to move x direction by 20 mm. Let's make it 35. Okay, then y, let's make it 35 again. $45. Okay, I think this should be fine. Okay, so now it's zeroed in that location. So it should mill it now. So I'm going to do the calculate again. Anyone remember what was the previous number here?
10, 20, 10. So move it to 10, 25, 20.
This was 10.
Yeah.
This was 25.
45. That's 20.
That is 20. Okay, this we don't need to, because what will happen if I change this, then it will use that as a origin to mill it. So we're going to mill a different board. Okay, so let's do calculate again. So if it was the previous numbers, then it should retrace the same track again. Okay. Okay, so now you can see that it's actually milling the board. Okay, so this is now the traces are all finished. Again, I can go back to view mode by clicking this button, pressing this button, and the lit RGB green LED tells me that it's in the view mode. All the thing will come all the way in front. I can use. Okay, so the next step for us is to actually cut this board so that we can take it out and then use it. And for that, as I said before, what we're gonna use is we're gonna use the 1/32" mill bit. So I'm gonna quickly take it out. The new bit. Move it back. Now we'll go back to our fab module, and now so this was the traces. What we're gonna do is we're gonna create a boundary now. So I'm gonna go to image PNG, and then select the exterior, which is just the boundary. Output again is I'm using the same machine, so it's a roll and mill. The process here is PCB outline. Yeah, so initially it was PCB traces, now it's PCB outline. Again, you have to make sure that you go back to your original position. So I'm just going to move to that position. Okay, so what should we do next? Any guess? Yeah, use the bit and zero it. So for that. Now because this is going to cut all the way in, it's not terribly important to be very precise in this case because it's going to anyway cut a lot. Okay, once that is done, I'm going to click calculate, which is going to create the tool path, and then just send it. Yeah, depth I'm using by default 0.6 mm. If it cuts through, then it's fine. If it doesn't cut through all the way, then we can change this to say 0.8 and then try. Does the thickness of the black line in the PNG has any bearing on? No. So what it does is look for a white island. So even if your thickness is very long, all it's gonna see is the boundary between the white and the yes. So I think it did cut all the way through. So then you just use the steel ruler and then just take it out. So this is your board. Again, what happens is as you use the mill bit longer and longer, it doesn't cut quite well. So you have some remainings at the edge of the tracks. So what we do is we use something called deburring, where we just scrape it like this. So this makes sure there is no like small debris left which are short circuiting two different tracks, because if it short circuits, then it's very difficult to make your board run. So I just simply deburr it in all four directions. And then you can visually check it if there is something left in between the tracks and take it out. Usually you don't see anything, almost like 95% of time it come quite well, but like 5% time you have to do some some sort of visual check. Okay, so this is the board which is ready now. What we're gonna do next is we're gonna stuff it. Okay. I would say not less than 10 mil. So 10 mil is 1 mil is 25 micron. So 10 mil will be 250 micron. So that will be, I think, 250 micron. 0.25.
So can we create a toolpath for any custom tool, custom diagram?
Yeah, so you can, in a software it tells you different inputs, and one of the input is the diameter of your mill bit. I won't recommend it when you are actually starting to use it. Once you get more accustomed with the instrument and the software, then you can do it. I never did it because it really gets tricky after you reduce the resolution below 1/64, because the copper track won't hold there. If you solder it, it will just come out.